Imagine a scenario where an engineering team needs to plan work, edit code, run tests, review changes, and preserve project memory, all without manual intervention. This is where our autonomous software delivery team comes in, a product that leverages the power of artificial intelligence and machine learning to streamline the development process. Let's consider a realistic request. A team wants to update a legacy codebase to improve performance and security. They input their requirements, including the code repository, testing frameworks, and review protocols, into our system. The output is a fully updated codebase, complete with automated tests, reviewed changes, and a preserved project history. The user boundary is defined by the input requirements and the output results, with our system handling all the complexities in between. The input can come from various sources, such as a web interface, command line tool, or even integration with existing development tools. The output is a transformed codebase that meets the team's requirements, along with detailed reports and analytics on the changes made. Our product's architecture is designed to handle this complex workflow, and it's built on top of several key repositories. The Opencode repository provides the AI-powered development environment, where agents can plan work, edit code, and run tests. The CopilotKit repository enables multi-agent frameworks, allowing our system to integrate with various tools and platforms. The crawlee-python repository handles browser automation and web scraping, which is essential for testing and reviewing code changes. The checkcle repository provides self-hosted monitoring and incident management, ensuring that our system is always up and running. Finally, the gridex repository offers a native database IDE with AI-powered query suggestion and optimization, which is crucial for preserving project memory and analytics. These repositories work together seamlessly to create a cohesive product that can handle the entire software delivery lifecycle. By integrating these components, our system can automate tasks, improve efficiency, and reduce errors, ultimately helping engineering teams deliver high-quality software faster and more reliably. With this foundation, our product is poised to revolutionize the way software is developed, tested, and deployed, making it an essential tool for any engineering team. A feature request arrives as a natural language prompt, like add a user login flow with email verification. The Opencode agent parses this, referencing the project's codebase and documentation stored in its memory layer. It uses the build agent's full access privileges to propose a plan, modifying the front-end forms, adding back-end authentication routes, updating the database schema, and writing tests. This plan is exported as a structured JSON workflow, triggering the CopilotKit framework's agent-native application layer. CopilotKit translates the workflow into actionable tasks, leveraging its AGUI protocol to maintain state across surfaces. It invokes the general subagent to handle cross-cutting concerns like security best practices. For the backend, it generates Express, Taji's routes and Passport, Anji's middleware via its code generation tools, while the frontend sees React components with form validation. These changes are pushed as a draft PR, but first the agent needs to verify data requirements. Here, the data flow branches. The agent uses crawlee-python to scrape example login flows from public websites for pattern validation, storing the results in a temporary SQLite database via gridex's multi-engine adapter. Gridex's AI integration ensures the schema aligns with the proposed authentication tables, auto-suggesting index optimizations for user lookup speed. The scraped examples are analyzed to confirm UX standards, then discarded securely. With the code changes ready, checkle's monitoring agents are configured automatically. The DevOps layer ensures the authentication microservice has uptime checks on the Login API endpoint and the Verify Email API endpoints, with SSL certificate monitoring for the domain. Infrastructure metrics like CPU spikes during rate-limited login attempts are baselined. When deployed, all alerts funnel into a Slack channel via checkle's native integration, with escalation policies defined in its settings panel. Finally, Opencode's plan agent reviews the Git history, updating the project's memory with the new features context. It documents the decision to use JWT over OAuth, references the load testing results from Crawlee's stress test mole, and logs the gridex schema migrations. This memory becomes training data for future agents, creating a feedback loop, where each deployment's telemetry like checkle's incident logs or gridex's query performance metrics refines subsequent planning. Each tool's APIs are tightly scoped. Opencode's proposed change triggers CopilotKit's generate code, which calls crawlee's scrape and validate, while gridex's execute query handles schema updates. Checkle's register service stands alone but binds to the same CI/CD pipeline event bus. The boundaries are clean. Opencode owns planning, CopilotKit owns execution, Crawlee handles external data, gridex manages persistence, and checkle ensures reliability. No component knows more than its immediate contract, but together they form a sovereign delivery pipeline. Start by standing up the core agent framework with CopilotKit. Scaffold a basic project using their CLI template, then integrate Opencode's Claude native agent as the primary development persona. Define initial agent permissions. Build agent gets full codebase access. Plan agent runs in read-only mode for planning and analysis. Use CopilotKit's AGUI protocol to wire the agents into a shared workspace. This handles message streaming and tool calls out of the box. Next, layer in crawlee-python for data ingestion tasks. Create a dedicated scraping agent that inherits from the base agent class. Configure it to run periodic jobs via Celery or your task queue of choice, using Playwright for headless browser automation. Set up proxy rotation through Crawlee's built-in middleware to avoid rate limiting. Test scraping workflows against staging sites before connecting to production targets. For monitoring, deploy checkle in a sidecar container alongside your main application. Configure uptime checks against critical endpoints. Then set up infrastructure monitoring using their one-line install script on your servers. Wire up Slack and email notifications for alerts. Create maintenance windows during deployment periods to avoid false positives. Finally, integrate gridex as your database IDE. Pre-configure connection pools for each supported database in your stack. Enable the AI Query Assistant by linking it to your Opencode agent instance via the MCP protocol. Test schema-aware suggestions by connecting to a sample database and running complex queries through the gridex UI. Local development uses Docker Compose to spin up dependencies, PostgreSQL for gridex demos, a mock HTTP server for Crawlee tests, and checkle's monitoring stack. Run agents in hot reload mode with verbose logging. Use env files to manage credentials locally, never committing them to version control. For production deployment, containerize each service with hardened Docker images. Use Kubernetes for orchestration, applying resource limits to Crawlee's scraping pods to prevent resource starvation. Deploy checkle with persistent storage for metric history. Set up gridex with encrypted secrets for database connections. Use a CI/CD pipeline that runs type checking, unit tests, and integration tests against a staging environment before deploying. Background jobs are managed through a central task queue. Crawlee scrapers run on a schedule, their outputs stored in a shared data lake. Opencode's build agent consumes these datasets to generate code changes, which are then reviewed by the plan agent. Checkle monitors job success rates and alerts on failures. Gridex handles database migrations as part of deployment, with rollbacks triggered automatically if health checks fail post-deploy. Security-wise, enforce least privilege access across all services. Rotate API keys monthly, encrypt sensitive data at rest and in transit. Regularly audit agent permissions, especially the build agent's ability to execute shell commands. Use checkle's incident history to track mean time to recovery and refine alert thresholds over time. The autonomous delivery system ties together agent workflows, browser automation monitoring, and database tooling through explicit configurations and open-source flexibility. Starting with Opencode, developers install via script or desktop app, configuring installation paths through Opencode install dir, or relying on defaults like home Opencode bin. The build agent requires LM API keys set in environment variables, while the plan agent operates read-only. CopilotKit extends this by initializing agent skills via npx CopilotKit install, assuming an LLM key is set in env, and supports framework-specific setups through React or Slack integrations using the AGUI protocol. Crawlee-python demands Playwright dependencies post-install, with pip install Playwright and Playwright install, while checkcle deploys via Docker or one-line agents for Linux servers, with environment variables for notification channels like checkle Telegram token. Gridex runs natively after downloading OS-specific binaries, requiring database credentials stored in system keychains. Limitations are clear. Checkle's Windows server monitoring remains beta, Gridex restricts ClickHouse to macOS, and Crawley's proxy rotation needs explicit configuration. Opencode's desktop version requires manual update checks outside the terminal install. Licensing spans MIT, CopilotKit, Apache 2.0 Gridex, and BSD3 Crawley, all permissive but varying in redistribution terms. Self-hosting checkcle or Gridex demands infrastructure for database connections or monitoring endpoints, while CopilotKit's backend tools require LLM billing accounts. To start today, a developer might run curl fssulch to install Opencode, then launch the desktop app and authenticate with an LLM key. They could then explore Checkle's demo instance with the provided credentials to monitor a test server. A natural question might be, how do I secure agent permissions when integrating Gridex with an LLM like Claude, a critical concern for database access control in autonomous workflows?